Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another lead code problem, that is combination sum 4. So we are given with an array of distinct integer nums and a target value. We have to return the number of possible combinations that add up to target. So let's understand this problem with an example. So suppose we are given with an array 1, 2 and 3, right? So if the target element is 4, what are the possible combinations of these three numbers that can add up to 4? So I can do 1 plus 1 plus 1 plus 1. 1 adding 4 times will be 4. 2 plus 2 will be 4, right? 1 plus 3 will be 4. 2 plus 1 can be 4. So these will, likewise there will be possible combinations. So one possible way is to find all the possible combinations are recursively, recursively finding all the solutions, find all the combinations using that we call backtracking. Now if we see the recursion tree for this, so if I have 4 here, I have 3 choices. Maybe I can subtract -1 and reach to 3. I can subtract -2 and reach to 2. I can subtract -3 to reach to 1, right? So similarly, if I have, from 3 I have 2 choices, I can subtract 1, I can subtract -1 and reach 2. I can subtract 2 and I can reach 1. I can subtract 3 and reach 0, right? From 1 also, if there are 3 choices, I can subtract -1, -2 and -3. So -1 will give 0 and this will give -1 and -2. So there are two base cases actually. If the target becomes 0, if the target is equal to 0, then it means that we have successfully identified a combination, right? So target equal to 0, successful combination. And now if the value is smaller than 0, if the value is smaller than 0, no target value reached, no target value reached, right? So if we recursively draw all the possible combinations, we will be having exponential time complexity. So at each node we are dividing 3 possibilities. So if we say, so it will be n to power t, right? At each node we are making 3 combinations, so it will be n to power t, right? N is the size of, where n is the size of the array, the combination array, combinations that is given, and t is the target. T is the target. T is the target. Now, so this is an exponential time complexity. Can we optimize this solution? So yes, we can use dynamic programming. Dynamic programming, tabulation approach. Okay, that will reduce the time complexity. So let's see the tabulation approach. So as we know, tabulation approach is bottom up approach of dynamic programming, where we find a solution for smallest subproblem, optimal solution for smallest subproblem, and use it utilizing that optimal solution of that smallest subproblem to find the solution for the larger subproblems. Okay, so the smallest sub problem will be f of 0. F of 0 means in how many ways, what are the possible combinations to get a sum of 0. So there is only one possible combination, that is to not to choose any element from this array combinations, that will give me the sum 0. So there is one possible combination. This will be our smallest optimal solution, right? Again, to get the sum 0, what is the possible combination of all these elements? Is that we don't pick any of the element from this array, then this will give me the sum 0. There is only one possible way. So now we will move from our smallest subproblem to the larger subproblems. So our target is 4. This is our largest subproblem. So if I go for 1, right? So what is the possible combination of the numbers from this array to get 1, right? So it means it will be the count of all the possible combinations for 1 minus 1, that is f of 0, right? As the number 2 is greater than the target, right? So we have to skip it, and we have to skip it the 3 as well. So for 1, so what is the meaning of f of 1 is, what are the possible combinations of the elements 1 2 3 to get the target as 1. So it will be the number of possible combinations to get the target 0 from 1 to 3, plus as 2 is greater than 1, we'll skip it, and 3 is greater than 1, we'll skip it. So it's only remaining to f of 0, and f of 0 we know 1, so it will be 1. For f of 2, what are the possible combinations for the target 2 from these arrays? So we will subtract 2 minus 1, that is 1. So it will be f of 1. 2 minus 2, it will be f of 0. As 3 is greater than 2, we'll skip it. So it will be sum of f1 plus f0. That will be 1 plus 1 equal to 2. So it will be 2. Right? So how do we read f2 and f1 and f0? So f2 means what are the possible combinations of these numbers from this array to get a target 2 is the sum of number of possible combinations of target 1 of these numbers plus the number of possible combinations of the integers from this array to get the sum 0. Sum of f1 plus f0, that will be 2. Now f3 will be 3 minus 1, that is f2. 3 minus 2 f1, and 3 minus 3 f0. So it will be f2 plus f1 plus f0 is equal to 2 plus 1 plus 1, that is 4. For f4 it will be f3, f2 and f1. The sum will be 4 plus 2 plus 1, right, equal to 4. This will be 4, 2 and 1, so it will be 7. So the number of possible combinations for the of the elements 1 2 3 to get the target 4 is 7. This is the tabulation method approach for dynamic programming. So let's see the code part for this. We have initialized our DP, that is target with the size target plus 1, and we have initialized DP0 equal to 1. that is the optimal smallest solution. Now we will call the helper method combination sum with the nums array, target and dp. So for from I equal to 1 and I less than equal to target, so what this is what we did, we started for 1 to the target. Now for every element in the array, the input array, we will make count, we will do count equal to count plus dp I minus nums j. So as we were doing 1 minus 1 f of 0, and for 2 minus 1 2 minus 2, so we were subtracting the integers in the nums array from the target, right? And we are making a count of it, and we are assigning dp of I as a count, and finally we are returning dp of target, because dp of target will store the final result. So let's run this program. So yeah, test cases are accepted. So I hope you like this video. If you like this video, please share and subscribe. Thanks for watching. Bye.